Hi, I'm Henry and I'll be talking to you about xenon. Xenon is the 54th element and a noble gas. Now, a noble gas is a gas which, or really an element, which doesn't react with other elements. However, xenon is an exception. Xenon has got a low electronegativity due to the fact that it's such a heavy atom, and so it doesn't have a very good control over its electrons, right? I mean, it's got less of a pull because there's so many electrons it already has, and it can actually react with some very highly electronegative elements. For instance, fluorine. Fluorine is a halogen, and it's got the highest electronegativity, and it only needs one more electron to get the amount of electrons it wants to fill its valence shell. Xenon, on the other hand, has got all the electrons it wants. It doesn't have more, it doesn't have less, but it doesn't have very good grip on them. So fluorine can actually steal it a little bit, and it can share an electron that it shouldn't be sharing to fill its valence shell. And so, because of this, xenon can actually form compounds. However, most of them have to be kept at very cold temperatures, otherwise they explode violently, which can be very bad, of course. And in fact, xenon is used commercially, and like you can have xenon difluoride, xenon tetrafluoride, xenon hexafluoride, xenon dioxide, all sorts of xenon compounds, and even like xenon with barium, and as long as it's also with oxygen or fluorine or whatever. And that's fairly interesting because it's the only noble gas which are famous for not reacting with anything that can actually react with other elements. And I guess it would have to react with fluorine at a very high heat to get enough energy and then be immediately cooled. So it's difficult to happen, for sure. But yeah, so that's pretty interesting. Xenon also was for a long time used in a trick, or like a magic trick, or just a fun demonstration, right? It's a... You know how helium, if you breathe it in, you get a very high voice, right? Well, that's because helium is very light, and so sound travels quicker in helium, and so then it moves quicker in your vocal cords, and you produce a higher pitched noise. And the reason it doesn't kill you is because helium is a noble gas, and therefore it doesn't react with anything in your body, and so you don't end up being chemically changed, and so you don't end up suffocating or getting burns or whatever, right? But they did the same thing for xenon, and xenon is much heavier than oxygen, so it makes your voice much deeper. But because it's heavier than oxygen, when you breathe it in, it collects at the bottom of your lungs. Of course. I mean, right? And because it's a noble gas, it can then spread from the bottom of your lungs, slip out of your lungs into your bloodstream, where it's carried into your brain, and then is released there, messes things up, and you fall asleep, or asphyxiate, or whatever. And that's sort of bad. And so people stopped doing that, and instead they use sulfur hexafluoride. Xenon can also be used in tricks because it's very heavy, right? And so you can float light objects on top of a casket of xenon, and that's another thing that it can do. Xenon has got some commercial applications. It is used widely as a noble gas because it's generally unreactive, even though we know that it can actually react with other elements. It's also used in ion engines, which is pretty awesome because it makes very good ions, apparently. It's all in all a very interesting and unique element, and is something that really deserves a lot of research, and is a very cool element in general. Also, I should note that xenon is the only noble gas that forms compounds well, like stably. Like radon can also form a compound. It's even less electronegative than xenon, but it also has no stable isotopes, while xenon has got the most stable isotopes after tin. So it's so radon is is radioactive, and as a result, it quickly dissociates, and so it doesn't really matter that it can form compounds because it can form the compound, and then it blows up, so it doesn't really matter. And then also helium and argon can kind of form compounds, but that's sort of iffy, and like the compounds are iffy, and weird circumstances doesn't really count. Thank you.